In this Precalculus unit, we are verifying trigonometric identities. There are many ways to solve this problem, and I will try to demonstrate a few. First, we need to familiarize ourselves with the trigonometric identities from our final exam formula sheet. We want to look at identities that may contain terms we see in our expression. There is a Pythagorean identity that looks like it could help. 1 plus cotangent squared of x equals cosecant squared of x. To use this identity, I will break the 2 in the numerator to 1 plus 1. My numerator will now be 1 plus 1 cotangent squared of x, which can be written as 1 plus cosecant squared of x. So my expression is 1 plus cosecant squared of x over cosecant squared of x minus 1. I will now break the fraction into two fractions with common denominator. 1 over cosecant squared of x plus cosecant squared of x over cosecant squared of x minus 1. Looking at reciprocal identities, 1 over cosine squared of x will equal sine squared of x. Since sine is the reciprocal of cosecant. The second fraction simplifies to 1. So my expression is sine squared plus 1 minus 1 or sine squared of x, which is one term with a single trigonometric function. Another way of solving the same problem is to use the same Pythagorean identity and write cotangent squared of x as cosecant squared of x minus 1. In this case, the numerator will be 2 plus cosecant squared of x minus 1 or 1 plus cosecant squared of x. And again, I will break the fraction into two fractions with the common denominator. I will use reciprocal identities to write the first fraction as sine squared of x. Simplify the second fraction and subtract the 1, and my final answer will be sine squared of x. If all else fails, a very common process is to convert everything to sines and cosines. In this case, I must use ratio and reciprocal identities. Cotangent is cosine over sine, so the numerator is 2 plus cosine squared of x over sine squared of x. Cosecant is 1 over sine, so the denominator is 1 over sine squared of x. Add the two terms in the numerator. We need a common denominator to do that, and the common denominator is sine squared of x. We get 2 sine squared of x plus cosine squared of x, all of it over sine squared of x in the numerator. To divide by 1 over sine squared of x, we want to multiply by the reciprocal, which is sine squared of x times 1 over 1. The sine squared of x in the numerator and denominator will simplify. We end up with the expression 2 sine squared of x plus cosine squared of x minus 1. we can use the Pythagorean identity, sine squared of x plus cosine squared of x equals to 1, to either write the expression as sine squared plus sine squared plus cosine squared of x minus, and replace the two middle terms with a 1. Sine squared of x plus 1 minus 1. Or we can use the same identity to express cosine squared of x as 1 minus sine squared of x. We will get 2 sine squared of x plus 1 minus sine squared of x minus 1. We will add like terms. This will give us sine squared of x, and the ones will cancel. And these are some ways we can use to work this trigonometric expression. On a paper and pencil test, the problem will be phrased differently as follows. Verify the identity 2 plus cotangent squared of x over cosecant squared of x minus 1 equals sine squared of x. To solve the problem in this case, we will start with the left side and work our way to get sine squared of x after simplifying.